Hello guys, welcome back to my channel. Myself Krupa v.kashyap from Sri Venkateshwara College of Engineering, CSE AI department. Today my topic is centroids. Centroid, center of gravity and momentum area. Centroid is a point where the entire area and shape can be considered to be concentrated for the purpose of analyzing its moment of area. So it is about where the majority of the mass is applied on a certain point of area is known as centroid. Key point center of gravity of shape, point of application of external forces, and we use the common formula is integration of x dA by integration of dA. Using this, we were able to find out few formulas for the following chart. First one is square. So for square, the even though it is not given here, square it is gonna be same. The centroid will be b by 2 for both. When you go to rectangle, the area is given b length into breadth. So breadth into height. Breadth for x bar we are gonna use it as b by 2, and y bar we are gonna use it as h by 2. But in case of triangle, you can see here, in case of triangle, the centroid is quite difficult to find, right angle triangle. So for that we are going to use the formula b by 3 and h by 3. Area is already known. Area of a circle is pi r square by 2, and here you can see the centroid quite clearly. So of a circle, the x bar and y bar will be the same. And when it comes to semicircle, the formula is pi r square by 2. For x bar, it remains the same, but in case of y bar, the centroid formula is 4r by 3 pi. When it comes to quadrant, the area of the quadrant is given by pi r square by 4, and x bar is denoted by 4r by 3 pi, and y bar is also denoted as 4r by 3 pi. Now let us see how to solve for an asymmetrical figure. So when we have an asymmetrical figure, now as you can see in the question right here, it is an asymmetrical figure. You cannot divide it into two equal parts. So when we consider such asymmetrical figures, we can break it down into simpler parts and calculate this area centroid and the moment of area about each axis. And when you sum it all up and use the formula given down here, we are able to find the y bar and x bar. Now let us see an example right here. So they're saying us to locate the centroid of the shaded area. So we're supposed to locate the centroid of the shaded area over here. First we can break it down into four components. First, the first component is a square. Second component you can take I've taken here as triangle, right hand triangle, and then there is an and there is a rectangle, and then there is at last a semicircle. So since they have not given what axis we're supposed to use, with we can take our own thing. Usually they says the bottommost part is considered the x-axis, and the leftmost part will be considered as the y-axis. Now we're gonna make a table. Here you can see area, x bar, y bar, x and y. It's not x bar and y bar, it's actually x, and we can consider as x and y. X is the centroidal distance along y axis, and y is the centroidal distance along x axis. And then here is the area. Since they're asking the shaded region, we have two parts which we can minus it at last. We can take it as minus, so we'll get the area of the shaded part. It is a simple trick. And then we're gonna find the area by the summation of all the values we have found out, and summation of xa and momentum of xa and xya will we're gonna take and find out the answer. First, let us divide this into four components. Now we're considering it as a square, a triangle, considering as a rectangle, triangle, rectangle, and a semicircle. Now you can see in the pictures I've given it with dimensions how we have considered the following figure. Now let us continue with the problem. First, we will as you can see we have taken first we have taken the rectangle 120 into 100 rectangle. So what is the formula for rectangle? We have already seen the formula for rectangle. It is b by 2 and h by 2. So y will be h d by 2 and this will be b by 2. The same for similarly using the table we can use all the formulas here. This is x. Then you can see here using these formulas itself, b by 2 and h by 2, h or d by 2 you can say. This is the one formula we'll be using, and you can see this is another formula we'll be using. B by 3 and h by 3 we'll be using a semicircle too. So now let's go to the problem. So after doing this you're supposed to calculate each component. First let us calculate the area. Area of a rectangle is b into h. B into h we have done it here, you'll get 12k. Same way we are using area of, next is we've taken area of triangle. Area of triangle is bh divided by 2, and then by substituting these values we'll get the values given in the table, and then when you do the summation of these we're going to use at last the formula which I explained for any figure, which will be x bar is equals to summation of whatever the summation of the moment of about x-axis, moment about y-axis. So moment about x-axis we're getting it as 75 mm, and moment about y-axis we're getting it around 750 mm. Here we have to make sure the calculation is done correct, since, and also you can see it is also given here. You have to make sure what is the shaded region given here. As you can see in the figure right here, the shaded region, we are supposed to minus the unshaded region. If we not do it the values may go wrong. So these are the stuff we should be careful about while solving the problem. Thank you once again for watching this video.